All right, today we are going over the day 4 and day 6. Unfortunately, I noticed that I do not have a day 5 in our notes packet, so I apologize for the miscount there. But we'll be going over day 4 and day 6. It just means we have one less page worth of notes to do, so that's great. Let's talk through our warm-up. We've talked through how to multiply polynomials, so our warm-up goes through how we take and distribute variables and things over and into those parentheses. So I'm going to do the last one because it's probably the trickiest one. I want to take this 4x to the third y and times it by both things inside of those parentheses. When I do that, if I have variables that are the same, I can multiply those together by adding their exponents. If there's a coefficient, that number out in front, I can multiply those two things together. But for the first one, I have 4x to the third times y times x squared. And then that would be plus 4x to the third y times negative 2y. So in order to do this first chunk of multiplication, I don't have any coefficient to multiply 4 with, so that'll just be 4. I have x to the third, and I multiply that by this x squared. So I'm going to add my exponents, and I'll get x to the fifth. Y doesn't have anything else to multiply with, so it's just y at the end. Same steps here we'll do for the second half. We've got 4 times negative 2 to give us a negative 8. X to the third, there's no other x's to multiply it by, so that's just x to the third. And y times y, they have that imaginary exponent of 1, so this would become y squared. And so I would need these things to have the same exponents on my variables in order to combine them. Since they don't have the same exponents, then I can't combine them, and that would be my final answer. Now, we've been talking about multiplying. We did a lot of that in the first part of the year. But what we want to do now is the opposite of that. I want to factor. And factoring is separating a polynomial back into a product. Now, this term product here does not mean some sort of thing that you're going to go buy at the store, right? Product here means a form of multiplication, very similar to these warm-up problems here, multiplying two things together. So in simplest form, that's what we had here with our 4x to the fifth y minus 8x to the third squared, y squared. So now, if I had something in simplest form, it could be 4a squared plus 8a. And in factored form, it would look something like this, 4a times a plus 2. And so what we're doing essentially when we factor something is we're trying to figure out what are the two things that I multiply together to get me that factored form. Polynomials that can't be factored are just like numbers that can't be factored other than 1 in itself. We call those things prime. Now, in order to do factoring with a greatest common factor, we are looking for the largest number that both of them divide by. Meaning that our first thing here is that we want to make sure that there are there's several ways to do this. There's not just one specific way. And so it really depends on the polynomial that we have and what we want to look for. So for factoring our greatest common factor, we've got 3 steps here. The first thing we want to do is identify the greatest common factor of the polynomial. The first thing I have to do is just figure out what's the biggest thing that both of these can be divided by. It could be a number, it could be a variable. So the first thing you'll want to do is check the coefficient. That's the number. I want to see what number can I divide both of these by, and what's the biggest number that I can divide both of these by. Then we'll look at the variable, our letters that we have in our expression. And we want that to have the greatest common factor. In other words, I want it to be maybe like a squared and a. They both have at least one a, so I can take one out of both of them. Once we have that, we're going to divide each term by that greatest common factor. And whatever we have left, we're going to leave in our parentheses. Whatever we said the greatest common factor was is going to come in front of our parentheses. And then, as always, we can check our work by distributing. So now let's take a look at a couple of examples here. So we want to factor each polynomial. Check your work by distributing. If a polynomial cannot be factored, we'll say that it's prime. So let's just start off with number 1. I'll do 1, and then we'll take a look at the next page here. So for number 1, I've got 3x plus 12. Well, first thing I want to do is figure out what coefficient, what number do I have in front of both of these, and do they have something that I can divide them both by? I have a 3 and I have a 12. And we know that 3 only has factors 1 and 3. But 12 is divisible by 1 and 12, 2 and 6, 3 and 4. Notice that they both have factors of 3. So I can take both 3x and 12 and divide it by 3. When I do that, I'll have x left over when I divide 3x by 3. So that'll be the first thing in my parentheses. And when I take 12 and divide it by 3, I get 4. Now, I want to check my variables just to be sure that I can't take anything out of both of those. And we should notice that there is only one x on our first part here. And since that is the only variable, there's no way that I can take that out of both things. So we divided. We want to check our work by distributing. So if I were to go backwards, I would take 3 times x plus 3 times 4. And that would give me back to where I started. That would be 3x plus 12. So this would be my factored form of that polynomial. Now, I want to take a look at some more examples. So let's take a look on the flip side here. There's a lot of them. Let's just take a look. Let's jump down to something a little bit bigger. Let's jump down to number 14. So for 14, I have a lot of variables and I have some pretty large numbers. So I'm going to use the side margin here a little bit too. Now I want to list my factors of 18. They're 1 and 18, 2 and 9, 3 and 6. 48 has a few more. 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. So we said the first step was to identify what their greatest common factor was. And out of 18 and 48, the number that they both share, that's the largest, is going to be 6. Now, they have 1, 2, 3 in both of them. But I really want the 6. That's what I want. I want the biggest thing that they have in common. That's what I'm going to pick. So I know I'm going to take a 6 out of both of these things. So I'm going to put that out in front of my parentheses. Now, last time, though, we said that there was no variable that I could take out of both of them. So now I want to double check and make sure that I can't take a variable out of both of these again. I have 18a squared b c squared minus 48ab c cubed. So what I'm going to do is I'm going to look to see which one has the least amount of that variable, and that's how many I'm going to take out. So if I have a squared and a to the 1, that means that I only have 1a on 48. So I can only take 1a out. I have b and b. Well, they both have a b in common, so I can take 1b out of both of them. The last thing is I have a c squared and a c to the third. C to the third is bigger, So I can take a c squared out of both of these. So I'm going to change my parentheses here to that c squared. So I'm taking a 6abc squared out of both of these. So let's just start our numbers divided by 6. 18 divided by 6 would give me 3. 48 divided by 6 would give me 8, and that's being subtracted. Then I said I'm going to take 1a out, so there's 1a from here. And if I take 1a out of 1, then I'm left with none, so that would cancel out. If I take a b out, then I have 1b and 1b. Those would both be taken out. And if I take c squared out, c squared cancels with c squared, and c to the third means that there's 1c left over. Now, again, I can distribute this and make sure that that would be the greatest common factor, that I would get back to the same thing. So if I take 6abc squared times 3a minus 8c times 6abc squared, 6 times 3 would give me 18. A times a would give me a squared. B doesn't change, and c squared won't change either, so that would give me that 18a squared b c squared. 8 times 6 would give me the negative 48, and then c times c squared would give me c to the third. Remember that this is a little 1 up there. And then I have ab, so that would give me my negative 48 abc cubed. So that's greatest common factor for us to start off the day there. Make sure that you do 2 examples from this back page here. Don't do one of the ones on the front page. You certainly could do one of those, and I can still check it, but I'm looking for this back page here. We want 2 examples from the back page. Now, for our next set of notes here, we've got a difference of squares. So we'll take a look here at what that means. So when we were talking about multiplying, there was a special section where when we multiplied our 2 parentheses, the middle term disappeared. They canceled themselves out. So that's what happens here when we have difference of squares. We're going to talk about factoring those difference of squares. So let's just for a warm-up, we've got 5m plus 1 times 5m minus 1, 5m times 5m, 5m times negative 1, 1 times 5m, and 1 times negative 1. So when we multiply those together, I would get 25m squared negative 5m plus 5m. They would cancel themselves out, and then I would have minus 1. So just as a reminder, that's what a difference of squares looks like. So we've got our couple of steps here. We want to first make sure that we actually have a difference of squares. So there has to be a subtraction sign, and you can square both things. So up here I have 25 and 1. Those would both be perfect squares. And then I have my factor, or my variable is an m squared, meaning that I have m times m. So now our second step, we would take a look, and we want to use our factoring rule for these. So we have our first official rule on how to divide these. Our factoring rule for difference of squares says that whatever I have a squared, b squared, I simply backtrack it to a plus b times a minus b. Now the trick is we have to figure out what the a and b terms are. What are my things that are squared in order to get my final product? So, and we can always double check that by distributing for our step 3. So I'll do example 1 here just to start us off. We've got a squared minus 4. Well, I have an a squared here, and I know that 4 is one of our perfect squares. I get that from 2 times 2, and there's a subtraction sign here. So that tells me I have a subtraction sign and that both things I can take the square root of. So I do in fact have a difference of squares here. So I'll have my 2 parentheses set up, and I'm trying to fill in these parentheses. I know for a fact that I'm going to have an a squared, so I'm going to have my variable a in both of these terms. Then I'm going to add and subtract whatever the square root is of my second term. In this case, I have 4, and the square root of 4 is 2. So I'll have plus 2 and minus 2. Now, if we were to double check that, we would have a times a plus 2 times a minus 2 times a minus 4. Plus 2a minus 2a cancels those out, so we would get that a squared minus 4 back to where we started again, so that would be our factor. One more that I want to take a look at. I want to take a look at number 8. So let's take a look at number 8 here. We've got 25x squared minus 49. So 25 is a perfect square. X squared, I get that from squaring something. And 49 is also a perfect square. So I can, in fact, do that one. I'll have my 2 parentheses set up. And I know that I have x as my variable, so I'll fill in x for both of those. However, I left a little space because 25 is also with my x squared. So I need to get the square root of 25. And we know the square root of 25, that's 5. So I'll have a 5x for my first part of my factors. And then we said the rule is to have plus and minus, so I'll fill in that plus and minus. And then I want to take the square root of the second term, which is 49, and the square root of 49 is 7. So I would have plus and minus 7 for my 2 parentheses. Again, we can multiply those together, and we would, in fact, get back to the start of where we had. 5 times 5 would give me 25x squared. 7 times 5x would give me 35x. Negative 7 times 5 would be negative 35x. And 7 times negative 7 would be negative 49. So positive 35x minus 35x, those two would cancel each other out. 25x squared minus 49 is what I'm left with, and that's what I want. So again, we've got a couple of problems here that you could do. We'll want to do 2 problems, 1 through 12 here. So you'll pick 2 of those and come back and check in with me. That's the end of our notes for today, though. Remember that if you have any questions, to always check back in, and I am happy to help.